Here is how the servo motor controller working. It's setting to 0 degrees, then 180 degrees, then 90 degrees. It's a simple model, SG90, but it's more than enough to research how to write a class for modulate PVR signals to control this servo motor. Hello to all engineers. Today I'm planning to show you how to work with a servo motor, specifically with model SG90, but we can implement all servo motors in general because it has similar logic, and we will create a kind of driver layer between main logic and interaction with physical devices. So first of all, let's look what is servo motor SG90. So the connection, we have 3 pins: ground, power supply, and orange, it's a signal we should to implement the simulation of PVR signal to send different stages of angle and rotating the motor. Let's by tradition create another device in our JSON configuration. So lesson 10, servo motor. Actually today it's a mini anniversary day, it's a 10th lesson. Okay, what we need, let's copy something from here. We forget the name. Something like servos, and describe our servo motor. So from the specification we have maximum and minimum angle. We can implement it in our class, but all what we need for connection, it's a pin for PVR modulation. I recommending to use pin number 18 from Raspberry Pi because it's supporting hardware modulation from Pi4J library. So okay, name simple servo motor SG19, model SG90. To parse the configuration, we need only a pin to control it, and we don't need this one. And we need an installation position, because if you're building something complex, some robots, cars, drones, you can have multiple servo motors, and to control it you need to know which motor you should to control to, for example, rotate rear wheels or front wheels. So by default we will have only installed sensor position 0, and I guess we already have the same pin for here. So I change it hardware configuration for here, and I believe I unplugged the buzzer, so we do not have the buzzer, and our display reconnected to different pin because we're using hardware pin for P modulation. Okay, so let's add the configuration to our where is it? Configuration local data class. Copy something like that. Servo config. What do we have? Name, hardware model, hardware version, then pin. We do not have this one. Installed sensor position, and we do not have this one. And add servos. Servos. List of servo config. Yes. Okay, let's create an interface, because we can have multiple models of our servers. So where is it? Hardware parts and interface servo. Then we need some function. I suggesting to understand from main thread what information will be interesting for us. For example, to know the actual position after rotation, or we don't know, maybe in different thread we already did some logic and we want to know the current position. So actuator is the same name for all movement engines what's converting electrical energy to physical energy. So actuator servo get current angle, and it's returning float. If we want to use precision coordinates, we need a float. Then we need a limit of movement, so the limit for this actuator from 90 to minus 90, the range will be 180 degrees. Okay, so if it will return the data from implementation, we want to know parameters of our servo. Actuator servo get angle range limit, the same float. Then we need to move. We want to move our servo motor. Actuator servo move to angle. Okay, what incoming parameters? First of all, angle, float, by default it's a default position. Then okay, Oh, my bad, sorry. I recommending to use one more parameter, as if so. This server has restricted speed of movements. Just you sending and the signal, it's moving, and you can't change the speed of rotation. But we can make an imitation to move for one angle multiple times in our loop, and we can modulate, decrease or increase the speed of rotating. So if we are sending the other parameter, custom time, we will use another logic. Custom moving. I'll show you in video how it's working and how it's moving. Time in millis, and it's an int, and by default it's 0. Then we need to parse the configuration to understand which implementation we should to inject in our body. So we already have a multiple times created logic for that. Just change it. So hardware model SG90. Servo config. Servo config. Servo config. Servo config hardware model. We need this one. Okay, servo, parsing servo, and we're receiving servo. I believe that's all. We just changed the name. Okay, perfect. Implement the specific class for SG90 servo. Servo SG90 servo. Implement everything from it. First of all, we need to parse Pi4J context. Then we need to servo config. That's all. So which hardware resources we need? So when we have a buzzer, we have a digital output. For servo, we need another type of hardware resource URL. It's calling PVM. It's a PVM from Pi4J. Then we need thread scope. Then we need another thread scope. If we move our servo with custom time in millis, because it's a different jobs. Custom time move red scope, the same job, and we need to remember and know the current angle position, because it's calculating for how much degrees you're rotating your motor from previous state. So private var current position in degrees. It's a float. By default it's that. Then init function build servo Pi4J servo config Okay, we need to build a params configuration for our PVM resource for our current pin. Param PVM new config builder. We injecting Pi4J, then I believe we already have something like that button. Yeah, we can copy something from here. Name, address, the same name, address. We don't need a bounce, but we need to set a PVR type. PVR type hardware. If you use another pins, you can set the software, but read the manual of your current Raspberry Pi or another models of IoT device. So specifically pin number 18 support hardware mode of PVR modulation. Initial state is 0. Frequency. We need a frequency, default frequency for PVR modulation. Then we need a shutdown 0. Then we need to build our configuration. Then we need to PVR Pi4J create Pi4J create params. Let's add a companion object for that. So okay, I'll just pass all these constants and I'll explain. I already calculated. The default frequency comes from SG90 datasheet. Where is it? Yeah, here is it. 50 Hertz. So let's add this one. Then all these angles comes from datasheet. Default mean duty cycle. I calculated that from the datasheet, so just copy those parameters. And default start position duty cycle. So this is a minimal speed to move for one angle. This is it. It comes from datasheet as well. And this parameter will be needed later. I'll explain why. So, okay. We built our then after we built our servo motor, we want to set it to the default position, 0 degrees. So let's create private fun, move to default angle, and just use this function and inject angle is 0. And immediately after we built our servo, move to default angle. Perfect. Okay. Actuator servo get current angle. That's why we need this one. So just return current position in degrees, and here we return default angle range. Okay, the default angle range in 180. But you can't calculate it like minus 90 plus 90. It will be equal 0, but the range is different. So we just set it as constant value. Let's implement our logic. First of all, we need two separated functions for precise slow movements and for default movements. So let's parse if custom is not null and it's custom more than 0, then we need another function like it will be an internal function, for example private fun move to angle for custom time, and we getting all these two parameters. Okay, and to do, we will implement it later, but for here we're calling this function and sending angle and current time in millis. Okay, else, and do our main logic. First of all, we need to get filter angle because we have a limits. Where is it? We have a limits 90 degrees, but if we send 110 degrees we can damage our servo. Actually it has some safety blocks in physical controller installed inside the server, but we never trust other devs. So we need to filter our angle if, well, filtered angle equals if angle more than default max angle, default max angle, else if angle less than default mean angle, default mean angle. Else angle. Okay, let's start thread scope, cancel the previous coroutine, then thread scope, coroutine scope, do everything in separated threads, dispatchers IO. You always can create your own dispatcher to control it in custom way. Okay, if we're starting to move our server, it means current position in degrees will be equal to our filtered angle. So while duty cycle in degree, calculating the duty cycle to set in PVR modulation, duty cycle by on degree. It depends. So if for minus 90 degrees, the duty cycle will be equal to, for plus 90 degrees, it will be 12. So if we want to set our duty cycle to 0 degrees in the middle of range to rotate it, the duty cycle, PVR duty cycle, will be in the middle between these two ranges. So it will be 7. And we currently calculating duty cycle in degrees, in degree, by on degree. Okay, default max duty cycle minus default mean duty cycle, we getting the range, then we dividing it by default, what is it, angle range. Okay, then we just PVR on so let's check it. Max minus min divide to angle range, then here is the formula, default start position by duty cycle plus filtered angle and duty cycle degree, then delay from where, from the data sheet. Here is delay 20 seconds PVR period. Okay, then we return true if our coroutine doesn't launching, we return false. Perfect. Okay, should to work, but let's implement another function to precision rotation with custom time. Okay, so if custom time in millis equals 0, we just return from this function, while filtered angle, we can copy the same actually. Filtered angle, bum. Okay, then while angle movement range, what it means and why it's need for us. Current in degrees minus filtered angle. So this servo can't rotate with different speed, so we just use multiple rotation by 1 degree with delays. So if the whole range rotation, it's cost around 1 second, but you can set one for move for 1 degree, then some delay, then move again, move again, move again, move again, and move again. And you like it's a simulation of custom pivot time. Okay. Then we need a range. We need a module, ABS. We need a module and some lab math. I already checked it. This logic it should have work. Oh, why it's neat? Because if you set the custom angle like a 90.5 degrees, so we need one extra cycle in the loop. The last one we will move for a half of degree. So we calculating, do we have this like a precision less than 1 degree of rotation? Okay, 1. It means angle movement range to int because we're preparing how much cycles we need for our loop, or angle range to int. Okay, then we have another coroutine scope. Why we split the coroutines? I'll show you. Because from this coroutine we're calling this function, but multiple times, like move for 1 degree, then we are increasing the degree, move for 1 more degree please, for 2 degrees, for 3 degrees, for 4 degrees. So we need a different threads. Custom coroutine scope, job plus dispatchers IO launch. Okay, our main cycle E in 1, 2 range. That's why we calculated. And why we use ABS function, it's a model of number, because we can get parameter minus 30 degrees, and this loop never will be implemented because range will be negative, so we need a model of negative range. Okay. Delay. Of course, delay. And which delay? We're splitting the delays to our range. Yes. Bum. 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 Too long. Then just calling this function Actuator Servo move to angle, but we need to send a specific angle, and each time its iteration of loop it will be different angle. So current time in degrees, because the current position always changing our each iteration. So if it's a filtered less than filtered angle, we set a current position in degrees plus 1 degree. Also current time in degrees minus 1. Okay, I believe that's all. What we need. Our servo motor, it's implemented. Let's add all logic to our servo. No, where is our avatar? Hardware body. Let's add some functions. We can add the same 3 functions like in our servo, but Actuator servo get but we can have a multiple servos. So in the list in array, so display position, servo position, servo position. Okay, let's copy that and let's copy. That's perfect. Then we need to implement it here. Okay, first of all, parse and add our servos. The same init servos, if pin not null. Okay, servos, servo configuration is valid. No, from servo name for the current servo, add body. Okay, let's add servos, add servo specific servo class. Okay, let's implement Actuator get current angle. Okay, no problem. If servo position less than 0, return, but we need to return float. We can't return false, so float like a positive infinity. If servo position less than body servo's size, it means we have return body servo position actuator servo get current angle. Then or return float positive infinity. The same logic right here, but limit, which is we can current angle, limit, and for here, if servo position less than 0, return false. If servo position less than body servo's size, return not false, body servo position actuator and receive angle, receive current time in millis, or return false. I believe that's all. It was not so hard. How do you think? Then we need to add a new JSON config. If you don't know what it means, we use general logic by multiple devices, and we just injecting the pin configuration and what hardware devices installed in our circuit board. But the classes are shared, so you don't need to create another logic for different configuration of circuit board and electrical chains. This is the magic of this project, what I use as example for teaching you how to work with Raspberry Pi and Pi4J GPIO library, use Kotlin and remote debugging, because we write this code from IntelliJ IDEA using Mac and then remotely install it to our Raspberry Pi in the same local network, but we can install it in anywhere on the planet using the external IP address. If your Raspberry Pi will be in another local network, just set up your main router, use NAT routes, and just open your internal and external port for Raspberry Pi. Okay, it's off topics, sorry for that. Okay. Lesson 10, servo motor. We don't wanna. Okay, let's, after we set up our display, servo motor movements use some delay. Then, because it's when the servo motor is initializing, it's starting to move to default position 0 degrees. So it's better to wait for a while. Actuator move to angle 0 degrees. Oh, servo position. Then to maximum angle. Then we wait. We don't need to wait actually. So here we don't want to use our buzzer because we unplugged it. But what we want to use for precision movements, for slow movements. Okay, let's copy that. When we press and hold the button, so our button has high state, we can move to opposite side our servo for a custom time. When you hold the button for 3 seconds, servo motor making a big movement for whole range limit. When you release the button, release the button, it's moving to opposite side. So you unpress the button, do nothing, and your servo starts to move in opposite side. So let's launch it and be sure that all was compiled without any errors. And just I'll listen. Does my servo working? Not. It doesn't. Why it doesn't working? Okay, servos. Let's be sure. Yes. Pin 19. We do have it. What's went wrong? Okay. Okay. Servo move to angle. SG90. SG90 the same. What's happened? I'll check it. It doesn't working. Interesting. I forget to do something. Let's body servos move to angle. Let's print a line. Boom. Okay. Interesting. Maybe I forgot something or made some mistake. Okay, let me figure out what's happening. As you can see, if I holding the button, servo motor rotating very slowly and precisely. When I releasing the button, it's returning to initial position.